Okay, now we have another example as a continuation. It is a rough tube. Here's x, here's z, r. Because it is tube, so we're going to use polar, cylindrical coordinates. And this is to assume it to delta, and this is to r as a radius. Gravity, pressure here and here is equal 0. There's no change in the cross section, so we can assume it as del b by del x equals 0. We already know it. And because L is way bigger than R, it is fully developed, bigger than 10. So steady state incompressible, fully developed, one direction flow. It is 2D flow, so it is one direction flow. We will discuss all of this. So blah 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 blah. Zeros. Of course, here there's no x direction, this is z direction, so pressure is not changing in z direction. So when I'm talking about R, yes, we pressure changing in R direction, it's okay. And no gravity in R, no u theta, no theta, etc. because it is one direction flow only in Z. You will find that this del B by del R equals 0. First equation, straightforward. In Z direction, no time, no UR, no U theta, only there's UZ, but because there's no Z direction, so no Z, del B by del Z, mu. We have change here. No, there's no change in theta, and there's no change in, sorry, no change in theta only, because it is, as we agreed, is one direction flow. Okay. Now, why we put this one is 0? Because we assume it is symmetric. That is mean UZ is same for all, so no change in UZ in respect to theta. Okay. However, we said this is we don't have theta to do direction R and Z. Okay. So we're going to summarize this equation. So forget the special case now. Okay. So rho UZ du by dz, anything by dz, because fully developed is 0. We forgot to make it 0. This one, this is 0. We forgot to make it 0. Okay, which is, and this 0. So it will become 0 equal minus del b by del z plus mu 1 over r del by del r for r del u del z by del r plus rho g, which is this equation. It's very simple. Okay, now we know that is del b by del z is equal 0. We agreed about this one before. If we make an integration from del z del b is equal 0, or we can write it 0 by the way, one direct. There's no need even to write it like this. Equal to 0 integration from 0 to L. Why we are trying to get this one? Because, yes, because we're trying to get some forces and some, we're trying to get some numbers, okay? That's why we put the integration with limited integration. However, if you don't want to do it with limited integration, you will have with functions, okay? But however, do the limited integration, all by dz, okay? Nothing change in respect to z because this del by del r, so it's not function of z. So we will find all of this plus function of r. Type, okay, why we put this term? Why you said that this b is a function of z only? So the function of r should be equal 0. See here. Then back to here. You see this one? We prove that is B is not function of R, and when we are doing our term that we know that is the pressure is not function of R, so it is function of Z only. We know it is becoming zero. Forget it. So this term should not be any function of R here. You get my point? Especially this one is a fully function of, because see, this one is a function of derivative, but it is there. But this is completely a function of R. For example, it will be like uh, without any Z, which is I'm trying to get. We have only two directions, Z and R, which is mean here there's no any Z. It is only R, maybe 6R squared plus 2R plus 1R, whatever. There's no any Z in it. So, and it is not changing based on R, and there is no any other term of Z which is compensate the R value. So this one should be equal 0. Okay, forget the special case. So now put again the equation. After you put the equation, separate algebra, you will get till del by del R equals this one. Make integration to R. So R will be R squared f2 etc. by R, f2z, another integration f3z, of course 1 over R integration ln R, etc. Put the bound condition at R equal delta, uz equals 0. So 0, blah blah blah. So we'll get this function. Okay, so uz is equal function 2, etc. This one function 3. Now at the Teflon. At the Teflon, it is stated that is due to there is no any friction here, and this one is very big. So the velocity here is the full velocity. So which is means the velocity is not equal to 0. It is the full velocity, an assumption. Which is mean it is zero friction here. Assumption. When you will go to here, so at R equal R, du by dz equal del R, because he said that there's no friction. There's no friction. I don't know what is the U it will be, so don't write capital U, because I don't know what is capital U. But I know that there's no friction, which is mean del z or tau is equal 0, which is mean del uz by del R is equal 0. Okay, return back here, del u by dz is equal 0. So this is equal 0, so this one go here, multiply, etc. So f2 it is equal, plug it again in uz, you will get this equation. Okay, so some algebra, you will find uz. If we need to calculate the shear stress on the rod, it is mu du z by dr. Use this equation, but we know f2z multiplied by mu, and delta is r. So r is equal delta. Here we need to put r is equal delta because we need to study it at the rod. Plug the numbers, put it, multiply by u. So this is the equation of the shear stress. Okay, if I'm going to fix that rod with a support, so I need to check what is the support force going to act on that rod. It is very simple. The area of the rod, the the area of the rod multiplied by the shear stress, area of the rod 2 by delta of L. So the force per unit length is 2 by delta tau, multiply some algebra. Of course, you will find it is in minus. Why minus? Because the force in the opposite direction of Z is down, force is up. You will find it here. So this is how we solve, how we think about about this one. This is very tricky. That is why we make integration, limited integration. For cylindrical coordinates, or for example, if you make a simple integration, you will make integration based on what? You get my point. Like if you start to say this one is zero from beginning, and you start to put, for example, assume this one is zero. So rho g equals this one multiplied by r divided by mu, and you have del r. So you will make integration in del r. It is the same concept. If you follow, it will be give you the same concept, which is we start to reach it here. Okay, so if you done it like this, what you see, if we start put it like this, put it together, so even if you didn't do this one, there's no any effect. So if you go direct and make it zero and put it left and right, it's continuous, correct, and you will get this. It is the same procedure. Okay, it's just for explanation why del b by del c equals zero, which is a simple way. Okay, now the hardest question or the hardest example. If I have a step bearing, which is mean this is bearing moving over grease, and there is load here. Here pressure atmosphere, here pressure atmosphere. But because there's a change in H, so I know that this delta B by del B by del X is not equal to zero due to change of the velocity in the cross section. So it will be increased, just 0, 0, but it will be increased in the middle. Okay. Yes, we know it is one direction because 2D fully developed, and we will assume it is fully developed because it is bearing. We said it is bearing, so assume that is the gravity effect is zero. Assume the gravity effect is zero. Just for yeah, this means pressure of the coming from the height h2, because h2 is way small, so assume it is zero. There's no pressure gradient in y. It is a good approximation. It is a valid approximation. Okay. Start 0, 0, 0. This is not 0. This is 0. This is 0, 0. This one. So this is equation in y concept, but we will assume this one is 0 because, oh, not assume, this will be 0 because we assume there's no gravity neglected. So del b by del y is equal 0, which is mean pressure is changing only in x direction. Okay, so the pressure is a function of x. Okay, it can be have some terms of y, but there is x, which is mean x will compensate the y terms. Okay, okay, so we can write the same equation, but not del by d, b by du, x, y, etc. What we done here, it is very straightforward. We just make integration one time. That's why there's f2x in respect to y. Another time. So u equals this term. Boundary condition number one. We know at u equals y equals 0, u equals 0. So this equals 0. So this is, but we have derivative term. When we have derivative term, and we know that this is changing in x direction due to the change of the area, not due to the pressure. If it is due to the pressure only, so we can use the approximation, the pressure start, pressure at the end, divided by the length, approximation to get this number. But we know that the pressure is not changing because the pressure is changing because change of cross section. So now let's return to our self. I'm just going to return back to what we done. What is the steps? Steps. We reach to u. There is first step, continuity. Second step, which direction we need to study with the opposite one. So this is dx, the opposite one. Integration from the full change in the h. We know this is 0, separate, make the integration, put it, put. Then after, try to put the change in 1 and put it together, only in 1. Then after, ask yourself, what is this h, what is the function of h in respect to x, and continue. Repeat. Okay. We will reach. Okay. Yeah. Continuity. du by dx equals 0 minus dy. Copy paste, copy paste. Okay. Now you remove u, put this equation. And from z to h. Okay. D by d. This not minus, is an units like this. Okay. So from here, make the integration in respect to h. You will find h cube, etc., etc., etc. Some algebra, you will find h total by u by over 2. We need it. So this multiplies this, plus this multiplies this, put it another way, u minus 2u, dh by dx, etc. by dx. Same concept, dx is going here, so it will be dx by dx. Integration of d by nothing, it is the same. Integration of this one is h plus c1, because it is dh, so it is c, it's not a function. So some algebra, db by dx equals this one, boundary condition. We know at x equals 0 to x equal 1. Okay, by the way, we tell ourselves where we need to ask, is it changing? When we reach to del b by del x, when we reach to this one, before making integration in x, we need to ask ourselves, h, is it changing in x or no? Okay, so again, even I didn't say it, you need to do it. You're going to do integration in x because to get b, but we need to ask ourselves, is there anything changing in x here or no? We know this one is constant. It is, yes, it is changing in x. So from x0 to x1, h is equal to h1. From 0 to L1, h is equal to h1. From L1 to L2, h is equal to h2. So we'll separate in two sections. The first section is this one. So b equal this one, because h1 is constant. h1 is a constant. So make the integration, you will find that c1 plus c2. And from x, and at x equals 0, we know pressure is equal b atmosphere or 0. So c2 is equal b atmosphere or 0. And from x till L1, and from x L1 to x equal L1 plus L2, L total, we know h2 is equal, h is equal h2. Same integration, but take care, c1, it is from here, it's not change. But when making integration again in respect to x, there is a c3, which is different than c2. Don't write a c2 again, okay? It is different. Same with the boundary condition at L2, be atmosphere, etc., etc., etc. We'll find C atmosphere is equal to this equation. We have a third boundary condition. It is very tricky. Not tricky, but it is obvious. Here, the first equation should equal the second equation. Very simple. So the first equation here should equal to the second equation, where at x equal L1. Put it at x equal L1. This equals this one. Some algebra. The only unknown is C1. So C1 is equal to this one. Okay. No need, I didn't write the full terms, but it will be very lengthy equation. That is the pressure is equal this one plus x over this one multiplied by this one plus c2, which is this one, and after it is equal this one plus this one multiplied by this one plus this one. It's very lengthy. However, now we need to calculate what is the force which I can put it over the bearing. The force is the how much is the pressure by the area for the first part plus how much is the pressure by the area, the integration from the second part. This force bear width. Okay, so the first part and the second part for this one by dx. Okay, if you start to make uh, the integration for the first one, it will be like this. Integration for the second one, it will be like this. You apply the limits, etc. I'm just putting for simplicity C3, as C3 is fully constant. It is a fully, if you go to here, C2 is constant. C3 is fully constant. It is H2, it's not, there's no any function in it. So C1, C2, C3 is all constant because it's not a function. So when you will start to make, you will get a force here, which is blah 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 plus blah 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 C1 plus L1 atmosphere, etc. Can you put it atmosphere is 0 plus this one C3 and C1. Okay, and if we start to ask ourselves, this is a question of the force, by the way. And if we start ask ourselves, okay, this grease, how much is the fluid of the grease going to run? Because if it is go like this, it will push some grease. How much is the fluid of that grease? You got it? So how much I need to keep always reserve grease to always have some grease here gone, not to let this one touch this one. So we need U. Okay, where you write it? You write it like this, but now we have dB by dx, which is this one. We know C1, so we can put the plug the numbers, but take care that is dB by dx is just two section. dB by dx is something from 0 to L1 and from something from 0 to 2. Because we are trying to get the flow rate, it is equal from the left section or right section. Take any section. So we took the left section because more easy. So we put the left section and we use H as H1 and we plug the numbers. Then we'll get an equation of U at the left section. So the flow rate is U du dy by width. So Q by width equal from 0 to H1 was the first section, U dy. So we got all of this. This terms here, this terms here, this terms here, the same term here. Then you will get the final equation. If you're trying to calculate the numbers, if I told you that is bearing going to move 0.5, mu is equal to this number, this is the dimension, you need to calculate C1 separately, C3 separately, plug the numbers here, you'll get the force, which is can take up to force per width, 808 Newton. And if you need to calculate the flow rate, also we calculate separately here, it is also the same concept. Plug the numbers here, which is from here, then you will get it, which is if you go to delta B, you calculate C1 already. You know this one H1, H1, so you can calculate delta B as a number. Then you will go to U, you have a number, you have H1 square over this one, H1 square 0.5, H1, I have a number, so you'll get U when you have U multiplied by from 0 to H1, which is multiplied by H1, then you will get how much is a Q, bear width.